Hello, today in this video, I am going to explain my machine learning project which is customer churn prediction. So first, let's understand the problem statement here. The customer churn means whether a customer will leave a company or continue using its services. This is a major issue for a business because losing customer leads to revenue loss and increased cost. The goal of this project is to build a machine learning classification model that can predict whether a customer will churn or not, means will leave a company or not. Now, coming to dataset, I use the telecom churn dataset. Which contains important features like here we can see customer age, gender, tenure, monthly charges, total charges, contract type, payment method, internet services, tech support, online security, customer support calls, and all. These features helps us understand customer behavior in the company. Before that, we'll gain data set. We'll load the data set. Here is the data set. Next, we have imported the required libraries here of machine learning, which will be used throughout the project. Next, I started with data pre-processing. First, I checked the dataset by analyzing its shapes, columns, and data types. Here you can see shapes, info, and describe and all. The dataset was clean and no major cleaning was required. Next, after that, I performed EDA, exploratory data analysis, also called EDA. Like in this step, I use different visualizations like histogram, and count plots to understand the distribution of data. Then I performed a bivariate analysis to see how different features of churn affect. Next, from this analysis, I observed the important patterns here, like customer with high monthly charges are more likely to churn. Customer with month-to-month contracts have high churn rates. Customer without tech support or online security also tend to leave more, and customer with short tenure are more likely to churn. Next, I performed the pre-processing of machine learning, data pre-processing. Since machine learning models cannot understand categorical data, I converted all categorical features into numerical format using encoding techniques. Here you can see after a correlation heat map, this is a correlation heat map. After this, outliers also have been detected. Next, in encoding techniques, I use label encoding for the target variables and one-hot encoding for other features. Then I applied feature scaling using standard scaling to normalize the data. Standard scaler, which is used in scalar to normalize the data. Basically, after that, I splitted the data set into train and test sets using 80% for training and 20% for testing. Then I handled the class imbalanced data using smooth, which helps balance the dataset so that the model can learn properly. Next, I trained multiple machine learning models. This includes here you can see logistic regression, Kn and K nearest neighbors, decision tree classifier, support vector classifier, gradient boosting classifier, XBoost classifier. After training, I evaluated all the models using accuracy score. Here you can see the evaluated models. Accuracy score. Based on my result, logistic regression achieved the best performance among the all model. Here you can see the best performance model, where here it is show logistic regression is the best model. Next, this indicates that the relationship between the features and the churn in the dataset is relatively simple and can be effectively captured by a linear model. To further improve performance, I applied hyperparameter tuning using grid search CV, especially on the random forest. It is here it is hyperparameter tuning we have performed here. Here it is. Here you can see hyperparameter tuning. This helped optimizing the model parameters and improved accuracy. Grid search CV and randomized search CV both have been performed. Here we can see the output, what have we get, and we have got a final accuracy of something like 0.797457, etc. After this, finally I compared all model using a comparison table and selected logistic regression as the best model. Here we can see the comparing model performance. I have compared the model and performance, and from here logistic regression are selected as the best model. Now coming to business interruption. In business interruption, the logistic regression model can help companies identify customers who are likely to churn. This allows companies to take early actions like offering better plans, improving services, and increasing customer satisfaction. Finally, based on my analysis, here are the key insights. You can see key insights. Customers with high monthly charges are more likely to churn. Customers with short tenure are more likely to leave. Customers without support service have higher churn rates, and contract types plays an important role in customer retention. Based on these insights, I have recommended the following. Companies should offer long-term contract discounts. They should improve customer support and technical services. They should provide a personalized offerings to high-risk customers, and they should focus on retention strategies like loyalty programs. So, in conclusion, I conclude that this project demonstration how machine learning can be used to predict customer churn and help business make better decisions. Thank you.